Okay, so does anybody have any questions from earlier in the week? Is there anything that people want, like people to post to the Slack, for example, or any confusion with stuff that people have posted? And I haven't seen anything in the Slack like this. Although maybe...
So I have a question that I wanted to pose to the group.
Ooh.
I wanted to know, when you do your analysis, do you log into a remote machine and do it all there, or do you copy stuff back? And I wouldn't have thought of this, except I think it was Ryan that mentioned this on Wednesday.
I have an answer.
Me too.
Okay, Britton, go. Then Corentin.
I make heavy use of the save as dataset functionality to save a lot of intermediate data products, bring them back locally, and then plot and play around, sometimes in Jupyter. Scripts on the clusters, save that, and then look at it.
This explains why you really like that particular function.
Why I won't shut up about that function, you mean?
Yeah.
Yeah. Exactly right.
Awesome.
Quarantine has one.
Yeah, I have a totally different way of working. Usually what I do is that I log in on like the front end of my cluster, and then I log in on the computational node, and then I do like 2 backwards SSH tunnel, and I launch a Jupyter notebook on the compute node. But the reason I do that is because I have very large simulations, which never fits in any of my computer, and I'm too lazy to get smaller data sets, which would probably be more efficient.
Can I ask a follow-up? Does your Supercomputer Center have the ability to launch notebooks yourself and you're not using it, or do they not have that? Because I know like at SDSC, you can run on Expanse, you can have it launch a notebook kernel remotely.
Well, I have to launch it manually.
So you do it yourself?
So, yeah, I have to like log in on the node and then launch the notebook and then create the backward SSH tunnels. It works like a charm until you lose your connection.
Right. And it looks like in the chat, Ricarda, you have a really similar working method as Corentin. Am I saying your name right, Corentin?
No one does.
Well, can you say your name and then I'll try to say it less wrong?
Yes, Corentin.
Corentin.
Oh, I'll try.
Okay. Yeah. I mean, right.
It's
always nice to be able to actually have the right.
So much retroactive shame for mispronouncing it now.
Yeah.
I'm totally fine, actually. I prefer like having my name butchered instead of people trying too hard to try to say it, and then usually not really getting it unless you're French. It was just a bad choice from my parents. I didn't know.
Right. Yeah. Cool. And then, okay, Josh, can you talk today? How's your mic doing?
I can talk. So the reason I couldn't talk the other day is that I decided to view everyone's presentations on my TV. So I was kind of in a different room.
Got it.
So that was quite good. I can recommend that. It's a much more relaxing way to watch talks, especially if they're like in your afternoon or evening.
Right.
How did you accomplish that? Did you plug into your computer or cast?
Did you use the Chromecast option or something?
Yeah, so I Chromecasted the whole screen to the TV. And it ended up being this kind of Rube Goldberg machine because the audio didn't cast. So there was actually 2 copies of me in the... One of me with my laptop for the audio and one with the desktop to Chrome. It was a complete nightmare, but I can recommend putting it on the TV part. Maybe not my technical implementation. Yeah. So Transmit is just a FTP client. It's a really nice one for Mac. And it basically like, it's like Finder, or I don't know, whatever you call, and I don't know, it like lets you see images on the HPC cluster quite nicely.
Cool.
Has a very attractive logo of it looks like a truck of some type.
Yeah, Panic software, like all of their stuff is very polished. Yeah, I'll just share my screen for 1 sec just to show you which desktop. This one. So like here, so it's this app here, and like it's just an FTP client, but it's quite a nice one. So like if I want to view this plot, so I'm logged into the supercomputer here, I just basically preview it and it comes up like this. So yeah, it's like completely like having it mounted as an SSH file system, but it works like unlike SSHFS does. And like, oh, you know, like I want to look at this plot or something.
It works well on Linux though, SSHFS.
Yeah, you see, this is a 32,000 by 32,000 pixel image. I will stop loading that before it crashes my computer.
I love the shock maps that look like craters on the moon.
Well, craters on the moon are shock maps, I suppose.
Fair enough.
That's right. Yeah.
I can recommend CyberDuck if you're not on Mac, and that's also free.
Mm-hmm. Cool. Yeah. Yeah, I do all my YTing. This is slightly less true now, but I do all my YTing on scripts on the cluster, and then move them over to my Mac to look at them, and also save as data sets a little bit. And then, because I always find that I didn't quite make the plot I wanted. And so, right. And so I just save it as a data set so that later I can make what I actually decided I wanted to look at and not have to go through reading in the whole giant data set. Oh, wow. There's a lot of cool ways to look at data here that I had not thought about. If anybody is not looking at the chat, you should look at the Zoom chat is having a lot of ideas here.
I had never thought of doing any of these things. All I do is just scripting on the supercomputer, like you said, and like download it. So, but I usually just convert it to raw binary. So, it's kind of older school.
Oh, actually, for those of us using VS Code, you can actually access. Like you can access from your local VS codes, like a remote VS Code on a cluster, and it can execute directly scripts on the cluster, which means you can edit with your local VS Code and run on the distant cluster. And like everything is handled usually quite nicely. Unless your cluster is running CentOS 6, in which case you're screwed.
So Matt, why did you ask this?
I was thinking about it because the other day I mentioned how I would generate just thousands of PNG files with weird names in my public HTML directory. And I was thinking about how inefficient that was, but also how in the early days with smartphones, I could occasionally look at them because it would generate, I don't know. Beyond that, I didn't have a reason. I was just wondering because everything moves so fast these days. It's really hard to keep up.
I hear you there, Matt. I have to pick and choose what I'm going to try to learn about. Yeah, that's interesting. My cluster also has the binder system. Is anybody familiar with a binder system?
Yes.
Yeah. So they have this binder system now because they don't want too many users of the cluster, but they want us to be able to share our data. And so you can invite people to look at your data via this binder system. And so that's an easy way to use like Jupyter notebooks to look at the data. There's some saving problems, which can be difficult to manage. Like you can't actually save if you're just signing in via the binder system. And so if you forget that, that's a huge bummer. But
So-
if you remember it, then it's okay.
So a project that Casper works on, so some of you know Casper, builds off of some of the binder technology and adds in shared file systems and things like that that can be mounted with CyberDuck and whatnot. It'd be cool to have Casper give a little demo of that sometime, because otherwise it'll just never get used.
Yeah, he definitely should. See if you can get him to come in 2 hours for the afternoon
trying.
talks. Cool. Well, we have 10 minutes left, and I know we have one lightning talk that we want to do. Right? I want to see Corentin's Blender.
Yes, that's right.
Yeah, so maybe we probably don't have to do like the quick lightning talk thing, or are you going to talk for like way more than 5 minutes if we don't cut you off?
Just stop me after 5 minutes, otherwise I will not know.
Okay, so we do
I'll-
need to cut you off. Okay, I
Okay.
like it.
Good.
It doesn't have to be as harsh as usual.
Okay, I'll just do the cutting off then. I'll set my timer
Okay.
on my phone and let you know when 5 minutes
Yep.
has passed. Okay. So yeah, I want to see this, and then we'll
I'll
have
also-
time to discuss the pros and cons of these 3 methods that we.
And we can also do some slide IO questions.
Oh yeah, but first let's do
Yeah,
Ron
yeah.
Tom.
But like we spent time yesterday coming up with great questions.
We did.
so,
We did. I don't want to miss out on them.
Yeah.
Okay, let me share my. Can you see my screen?
Yes.
Yeah, cool. Okay.
Cool prompt.
Yep. There you go. Nope. That's my presentation. All right. So actually, it's I initially wanted to just show that you can do the same thing as what Maxim did in Blender, and then I realized that it's also a good occasion to present one way of thinking about data analysis, which is slightly different, but also can be related to what we've discussed yesterday, which is node-based analysis or node-based addition. So essentially, if you look at the bottom of my screen, I'm going to just describe what is happening here. But essentially, the way Blender works to create shaders, so shaders are just a way of processing some inputs and getting some output, which is the top window here. The way it works is you've got all these small nodes, and each node says some like inputs sockets and output sockets, and it's really convenient because they're colorized. For example, the blue ones are vectors, the gray ones are just values, the yellow ones are RGBs, and then you can think about all sort of different stuff that you can put as input or outputs. But what's really great is that you can also group them together. So imagine that you have like if you imagine like analyzing your data as having like multiple small steps, and each of these steps you can represent as taking some inputs and giving some outputs, then you can also group all of these nodes, transforming your data and create one big node that looks small, but is actually quite big. Well, this one is not a good example. For example, this one, yeah. And then here I've got another group of nodes, etc. And all of them, they act on the data in some way, and then I just gather them and it makes something that looks clean, even though it's not. Okay, and then now to the point. Where what do I want to do? Yeah, okay, cool. Yeah, this goes here. So this is really like not clean at all. But in Blender, I can load in some textures, which I stole directly from Maxim. So I've got the temperature, I've got the star density, I've got the dark matter density, the neutral hydrogen density. And then you can imagine like taking these like 2 images and then I create something called a mix, which is exactly what it says. It mixes two images together. What is really great is that this factor here that I'm tweaking, that controls which image is shown, doesn't have to be a constant across the entire image. It can actually be a mask exactly the same way as what Maxime was showing. So imagine that I've this mask here, so it's gray on one side and white on the other one. If I connect the output of this mask to the factor here, poof, now I've got like a mix of the two images. So I've got like the stellar density on the left and the I can't remember which one on the right. And then I can do the same thing with like other images. And then I can also like mix two of the composite images together. So I get like 4 quadrants, which is what I get here. And what is cool also is that I can ask Blender to rotate my images as input, which is happening somewhere in this gigantic mess. And I can't, yeah, it's here. For example, you can say, you can ask Blender, okay, well, you take your input, you rotate it by some angle, and then you put it as outputs. So let me show you what it does. Okay, so here I'm connecting the socket of my stuff with 4 quadrant, and if I press play, yeah, I got something that looks similar to what Maxime did, except it's less clean, but it's rendered in real time, which is really great. But one thing I really like is the idea of composability. So here I've got like 4 rotating quadrants, but I also, for example, wanted to have something a bit more wavy like this. So I have a nice gradient here and no gradient on the other side. And if I replace, whoop, whoop. So essentially it's the same function that takes this similar inputs and outputs like something very similar. And so I can just use it as a drop-in replacement and get something much more psychedelic, which looks not informative at all and not useful at all, but it looks good.
It does. It's very pretty.
Yeah, and then, well, you can do all sort of crazy stuff. Like I created like a yin yang to really like, there you go. Which it's a bit pointless, but it's fun. But really what I wanted to show here.
That was my 5 minutes. So
okay,
finish up.
Cool. Yeah. So essentially, I created like the mask generation as just like some very simple function, which gives 2 outputs, which are just like a 2 binary masks, and then I can like replace any of these nodes here by another one that has the same API. So it's really neat to represent like APIs and group stuff together and like get composability on your data analysis. So I guess there's something we could draw from in a day, in some day, or for YT5, I don't know. And I'm going to stop there because my time is.
Thanks for bringing up YT5, Corentin. Already looking to the future.
Yeah.
Perfect.
I love that. That was so cool.
That was
Corentin.
awesome.
Thank you.
I think the swirly one is a nice hypnosis technique. We could hypnotize people. Everybody should love Astro.
There is a guy running a YouTube channel called Microtiles, and he's only doing that kind of stuff. And it's really mesmerizing. You can waste a lot of time watching it.
I feel like we should make some cool YT music videos with that and then post it on the blog, slowly hypnotize people with some sweet Blender images that maybe would never be in a paper, but could be on our sweet website, you know?
Yeah, that's right.
Yeah.
That's a good idea. A research note.
Yes.
I'm pretty sure that's what research notes are for.
So should we do one slide IO question?
Oh, yes, please.
Okay,
Ooh, good.
Thank you for putting up the tile. That's so helpful.
Okay, there we go.
Da-da-da. Oh, yes.
Now, these are all real units. Is that right?
Yes.
I'm very amazed. No, they are not all real units.
Which one don't you think is real?
Pirate Ninja?
It is real.
No.
I think it's
What
a
do you
unit
measure?
of power. I think it's a unit of power.
Wow. Well, then that's obviously going to be my
Yeah.
I feel
And an
really good about
outhouse is
that.
a type of, I think it's like a pico barn. It's a very small barn.
That's good. I mean, that makes a lot of sense to me.
Yeah.
In my visualization,
In your,
that is basically a pico barn.
yeah.
My mental visualization is,
Do
and we have some fans.
Do we have a coverage for which of these are in unit? Maybe Josh can talk about that.
Yeah. We might have to post this, ask everything about unit. Wow, I'm very happy banana equivalent dose is doing so well. I'm just going to say.
Is that a nuclear thing?
Yes. Yeah, it's like, it's more used for science communication to say like, this is how many, like, if you get this X-ray, it's the same as eating this many bananas or something like that. So it's supposed to kind of give context to like what your dose would be.
Nice.
Mm-hmm.
Okay.
Okay, well, it looks like we have a tie, and very happy that banana equivalent dose is.
Oh no, but Pirate Ninjas is not in unit, which I have a really hard time reading as unit. I definitely always read it as UNYT. I thought you all were like, when you first announced it before I read anything about it, I was like, ooh, we're UNYTing. And yeah.
That is part of the joke.
Okay, good. I'm glad it is, because I got it while I didn't get it. So that's perfect.
Mm-hmm.
Good. All right. Well, I think it's time for our first talk.
Yeah.